Hello, everybody. So I'm very, very excited to start the MICCAI Startup Village 2026. Um, Before we will talk about the startups who are participating here and everything, I'll just mention that the Startup Village, the idea of the Startup Village is to highlight startups that are their topics are closely related to MICCAI, to medical imaging, and at the end of the day, we want to see the research going and makes it into the products. So here it's really a nice way to see what's going on and what's new and which new startups are here in the field. And maybe before I will mention what the winning startups will get and everything, I just want to invite Nicolas Reike from NVIDIA and of course also from the MICCAI Society, who is the founder. She was the founder together with Marius of the Startup Village, and she'll talk a little bit about the Startup Village in previous years and how it was founded and everything. So yeah, Nicola.
Thanks a lot, Bella, and welcome everybody. It will also give some time for the others to join because I think people are still joining. It's great to see so many startups here today. As Mela mentioned, this is not the first edition of the Startup Village. It started back in the day, 2020, and I was not intended as the founder. It started as a conversation with the general chairs of MICCAI 2020, where we said, there is so much amazing research at MICCAI, and most of the researchers are not aware how much of this actually make it up into a product, and how many startups actually come from the MICCAI Society, because we did not really touch these topics there. We did not give us really space for a discussion like this. So we are starting to think about how can we be more inclusive? How can we show the startups that are related to MICCAI? So some are coming from MICCAI Society, or some are related to MICCAI Society. So we were thinking about how to establish a format that does not make MICCAI an industrial conference like other scientific conferences have slightly become to, but how to create a synergy between startups related to MICCAI and MICCAI. And it all started, as I said, in 2020. It originally started actually as a village, but you all know 2020 was a special year. So the first year was a virtual, completely virtual startup village, and from there it evolved. We tried it as a completely in-person event, and we tried different things. And so this is the second time that we do it in this format. So it's a hybrid format because we want to give as much visibility as possible for the startups, as well as everybody should be able to see the MICCAI related startups. So we have the virtual pitch competition, which is happening right now. And from this virtual pitch competition, all the startups, of course, can come to MICCAI and will be included. However, the three winning startups, they will get a dedicated booth at MICCAI to start conversations with the researchers to showcase their product live. They will get like the winning startup will get a travel award and so on. So Bella will go through the details as well. But yes, I'm very happy that this all continued throughout the years, through all the complications, and looking forward to the event today. So back to you, Bella.
Um, Yeah. Okay. Thank you. Thank you very much, Nicola. So I will a little bit more about this year's format, which is like Nicola said, is quite similar to the previous year because it was very successful in this format, and it gives people the opportunity to join online, even those who cannot travel to MICCAI. And of course, also in MICCAI itself, there are the booths and there is also a lot of interaction with the startups. In terms of how it works, so first we have startups that are selected for the pitch competition. So we had 13 applications, and only 9 startups actually were selected for the pitch competition. And of course, even this competition, it gives visibility, and everything is posted in social channels and the newsletters, and it also a very nice during this pitch competition as well. And then the top startups, the top 3 startups, so they will get a dedicated space at the MICCAI 2026 exhibition area. So this is the first thing. They will also get a free registration to MICCAI 2026, so it will facilitate their coming there. And also the first place will get $1,000 travel award. So this is in addition to the registration. The winning startups also will get a invitation to the MSB networking event and to serve as networking partners. So I don't know if you're familiar with this event, but at MICCAI, we have a networking event where actually it's not just for invited speakers. It's also for everybody, free to come, whoever attends MICCAI. And the networking partners, they are kind of having a round tables around them. So it also to give more visibility to those winning startups. But every startup here is very encouraged. If you are in MICCAI, just join the networking event. What I forgot to say, yes. So those are the winning startups, but also everybody is also encouraged to connect to a NVIDIA Inception program and a AWS startup program. And you can take it from there. You can just send me email and I will connect you and just reference you to the relevant people. Okay, so this is kind of the general what the startup get and the general picture. In terms of the startups that we have here today, so of course we will see each one of them presenting here and here in-depth presentations. You can see here we have 9 startups. The way it will go, we will have each 3 startups presenting one after another. For each has 5 minutes exactly. And after the presentations, we'll have a Q&A session with the judges. This is how it will work. Those will be 5 minutes. Okay, so after 5 minutes, I will need to cut people because we are short in time. So please be mindful to that. Okay, in terms of the voting system, please, I'll just mention. I'll just mention how the votes go. So I see people are saying that maybe there is an internet issue. Is everything okay? Can you hear me well?
We can hear you well.
Okay, good.
Yes, yes.
Okay, so it's not on my side, which is good. Okay, so in terms of the way the scoring is done today, we will have a judging of the startups. We'll have selection of the top 5 startups from the 9 startups, and the way it will go, we'll have both the audience vote and the judges vote separately, and then we will combine the two to have the final 5 startups selected. So this will be today. So for all the participants here, listen carefully as well. It's not just for the judges, okay? Because you are active participants and will need your votes. And like you see here, we'll have 50% judges, 50% audience vote at the end of the pitch, and we'll announce the 5 startups that are going to the next round. And then after that, the judges, after the pitch competition, the judges will look in depth into the materials of each one of the startup, and they will rank them based on predefined criteria. And finally, the winners will be announced in July 28th. Okay, so in terms of the judges that we have here, so I will quickly present the judges, but then I want each judge just to say a few words about yourself as well. Okay, so be prepared. So we have Nicolas, who you already heard. She's also helping to organize this event. Nicolas from NVIDIA and the MICCAI Society. We have Alex from AWS, and we have Wolfgang from ImFusion. And of course, myself, I'm the moderator, and I'm from the University of Haifa. Nicolas, do you want to say a few words about you and about NVIDIA?
I keep it very short. I think everybody knows NVIDIA. We are very happy to support MICCAI in all the ways. And I have two roots. My roots at MICCAI are way longer than at NVIDIA, but I'm at NVIDIA since more than 8 years and leading the technical team in EMEA, focusing healthcare life science. So right in the home of MICCAI. So over to you, Alex.
Thanks, Nicola. So I also keep it brief. Working at AWS and the healthcare industry team, and in that capacity, supporting all customers we have in the medical imaging space, including radiology, digital pathology, and actually all ologies. Of course, I have more of a commercial focus in the AI space because we are working with all of the startup scale-ups running on AWS. Therefore, please also expect some business relevant questions from my side, but really looking forward to the session today. Thank you. Wolfgang, please.
Yeah, so Wolfgang, very pleased to be here. I'm the founder and CEO of ImFusion. Our company exists since 2012, but the roots of everything that I do is really all originating from the MICCAI community. I think the first one I submitted the paper to as a PhD student was 2004, and the first one that was rejected, and the first one I attended was 2005. And so we are a company that is a mix of a contract research company, a software company, and an independent R&D lab. And we basically every year have a booth at MICCAI, and we do a lot of relevant work across medical imaging and guided surgery. And as such, I'm very excited to hear about the startups coming out of this pitch competition. Thank you.
Okay, so now I want to invite. We will start our first batch of companies presenting their work. So I want to invite Bell AI to present their work. Please, the speaker of Bell AI, can you just
Good morning,
maybe
good afternoon. Can you hear me
yes,
okay?
yes,
And Dr.
great,
Bella, I'd like your help with the slides. I'll say next if that's
yeah.
okay, with your permission. That way we can have the conversation
Y-
smoothly, if that's okay.
Yes, yes.
Thank you.
So please see if you have control. You should have control now.
He was asking if you could move forward.
Yeah, I think
Oh,
better if
moving
you do it.
forward?
Yeah,
Oh, okay.
better if you do it because there's always a delay on my side. And that
Oh,
way,
okay,
so,
okay,
yeah,
okay. So we'll
okay.
start. Okay, no
Okay,
problem. So we will start. Yes.
thank you. Good morning. Next slide, please. My name is Lee Tran. I'm the CEO of Bell AI, and with me are three women scientists, clinicians on our team, Dr. Hang Nguyen, Julia Souffle, and Dr. Yoon Kim. They're the brains behind this work. We focus on computer vision for the skin. And the reason why we use the skin as a place of impact is because humans are not good at identifying skin disorder. This literature from MIT, Stanford, and Duke Medicine shows that general doctors get only 19% accuracy when looking at digital images of the skin. It was a global study, 39 countries, about 1,000 doctors, not assistants, but physicians. Worse, if the skin were black, only 15% accuracy. Next, please. Our work allows doctors and every healthcare provider to see everything, all skin tones, all diseases, and measure everything. In fact, the WHO is a customer. So is Dana-Farber Cancer Institute. For women who are fighting breast cancer, they lose hair. We help patients and doctors identify the risk of hair loss for better treatment care. And last year, we won $3.5 million from ARPA-H. Next slide, please. Next slide. So what is this skin disorder? You look at it, it's brown skin. We can help. Next slide, please. Our topological voting method shows that the patterns here look similar to MPOX. And then we comb through the evidence, the PubMed literature, and explain what MPOX is. So we show not only the image, but the explanation for evidence that it is believable. Next slide, please. This is a fair skin patient, but it's hairy legs. The question is, can the AI see through the hair and look at the disorder at hand? This interpretation shows the pattern suggests it is psoriasis. And with psoriasis, you have to measure it on how severe to provide the right guidelines. And here, this is a treatment psoriasis guideline by the AAD. Next slide, please. This was interesting. Cancer patient, right? Drug eruption because of oncomedicine, similar to breast cancer patient, but this is for a different treatment of cancer. So we can then allow doctors to prophylactically treat the skin rash so they can stay on the medication. Otherwise, the consequence is different. So 3 examples. Next one, please. So the last slide here for images shows that we're multilingual, which means whatever the skin condition is, we can explain it in the language of choice, making this impact global. The patient on the left, black skin, which general physicians only see 50% accuracy. We not only see it, we could put it in Hindi language. On the right, acne patient. We see it, we measure the severity, and we also give it in the language that's required. So the impact is global. Next slide, please. Now, what else can we do with computer vision? Why not put language models in as well? Because sometimes the doctors are wrong. Next slide, please. In this case, this is an image that every doctor got incorrectly. That's all they got, this mass. And if you look at the image assessment, it says fibroma mole. But if you added, next slide, please. If you added where the location is, next slide, please. It shows that you see in red, the reign of that mass, the region is near the anus. Then it shows that this is not a fibroma mole, but an HPV disorder. So we take both computer vision and language model, combine it into a really context-based, evidence-based result here, which makes it very impactful, right? So computer vision and language model for context, because sometimes doctors only get such limited information from that image. Next slide, please. What else are we doing? We measure and we explain everything. For skin cancer rash lesion, not only can we take a photograph, we explain it. This is just a benign mole. Next. We also explain why it's benign. We use the ABCD rule. A for asymmetry, B for border, C for color. Next, please. Make it evidence-based. We show it with literature. Next, please. And next, please. We measure it. You see? Next, go back. We measure it. You see, we can take that ruler and measure and timestamp the size of that mole so that 6 months later, if it grows, you have evidence that you should take it off. Next slide, please.
You have 20 seconds.
Thank you. We then also can measure the thickness of the lesions, the branch color, and all of that drives a risk factor of that rash. And ultimately, we would take this technology and bring it to every family. So you can take a photograph, put it on your mole. Don't wait 6 months for a derm appointment. Know whether or not this is risky today. Next slide, please.
Okay, sorry, we need to cut, but
that's our team.
Yeah, that's your
beautiful team, beautiful AI. Thank you for the opportunity. Let me pause.
Okay, yeah. So next, Convia.
Do we have questions yet, or only after the words?
No, the question is at the end, after 3 startups are presenting. Okay.
Okay,
yes.
Thanks. I think I have remote control.
Yes.
Hey everyone, I'm MICCAI and one of the 4 co-founders of Convia, which is a spin-off from the University of Lübeck in Germany. And during my PhD here, I spent quite some time working on medical image registration. And one question kept coming up for me and also for my colleagues, and that is, if this technology has so much potential, why is it still hardly used in the clinic? And that's exactly why we founded Convia.
Sorry.
So Image registration has become a key technology in medical image research. It enables multimodal image fusion, longitudinal follow-ups, atlas generation, motion analysis, and many other applications. But during collaborations with clinicians, we realized that everyday clinical practice still looks very different. So radiologists often compare images side by side. Tumor follow-ups still rely on manual slice matching and maybe segmentation only. And image fusion is often limited to rigid alignment or a few manually selected landmarks. As a result, clinicians spend their time comparing images instead of interpreting them. So these workflows are very slow, inconsistent, and difficult to scale. More importantly, they reduce complex 3D patient data to a series of static image comparisons. And we believe we're still only using a small part of the potential hidden in this data. So with Conveyor, we want to change that. We provide a universal image registration engine that can be integrated directly into existing medical imaging software, such as radiotherapy planning programs or PACS viewers. And instead of developing a registration algorithm for every individual application, the Conveyor module can simply be integrated as an infrastructure component. Our technology aligns images from different modalities and also time points precisely, and it provides both the aligned images and the underlying deformation field. But we believe registration shouldn't end with this deformation field or a warped image alone, but the displacements contain rich information, for example, about how anatomy moves and how it changes over time. And by making this information accessible, we can enable entirely new ways of visualizing and quantifying patient-specific anatomy. So here, for example, we use the deformation field to visualize respiratory motion just from 2 CT time points. So our solution is built on years of research in medical image registration of the working group of Professor Matthias Heinrich. And the group organized the Learn to Rec first as a tutorial and then as a challenge at MICCAI since 2019. And it has become the benchmark for registration in the community. And Conveyor's technology is mainly based on a method called convex Adam that has consistently achieved top rankings in the Learn to Rec challenges over the years. And we now build on top of that by combining convex Adam with a foundation model for feature extraction and transform this research into a robust registration platform that can be used in real clinical software. So therefore, we are developing Conveyor with medical device certification in mind. The core technology behind Conveyor builds, as I said, on convex Adam, but we have filed a patent for this technology, which is currently under review. And convex Adam itself has been published in TMI. So going from research to business, we aim at a B2B software licensing model. Smaller companies can integrate Conveyor through our SDK, while larger medtech manufacturers can license this at an OEM software component. Our focus is not on building another standalone application. Instead, we aim to become the registration infrastructure across radiology, radiation therapy, AI imaging, and also clinical research. And together, these markets represent well over €1 billion in addressable opportunity. Our founding team combines scientific, clinical, and business experience. Christoph leads research and algorithm development. Yuri brings expertise in quality management and regulatory affairs. And Sabrina has years of experience in a medtech startup and acts as our business lead. And my role is to connect the technology with clinical workflows, data, and regulatory requirements. We are supported by an excellent advisory board, including, of course, Matthias Heinrich as a mentor, and as well as clinical partners and software experts. So as researchers currently becoming founders, we believe that the best technologies are developed together with the community. And that is why we keep coming to MICCAI and would also like to come this year. And we are looking for expert feedback, clinical collaborators, and industrial partners to help us refine Conveyor and bring AI-powered image registration into the clinical practice. Thanks.
Thank you very much. Okay. Even 15 seconds before time, that's great. And next are Coral Kessel. Who is the presenter? You want me to go over the slides or?
Sure, I could just say next slide. I do agree it's a little bit more conversational. You can go to the next slide.
No problem.
Okay, well, hi everybody. It's really cool to see everybody's presentation, see how everybody's converging on similar answers. It just gives credence to the science community, so that's such an honor to be a part of that. But Anyway, without further ado, my name is Zachary Malahi. I'm the founder of Coral Castle Laboratories. I graduated with a master's degree in medical physics in 2021. I spent about 4 years as a clinical medical physicist, so I have a little bit of experience with the physical nature of this problem. I did my master's research in automated pattern recognition, so this is a problem that's very pertinent to me. And then about a year ago, I made some of my own advancements in my math, and I'm using that to found the company. Next slide. So at the essence of what we're doing, we're essentially asking the problem of a physical system of how does an imaging system warp circles, and we just come up with a good way of expecting circles using what we call a phantom to actually scan. We scan a phantom. It's like a physical widget that you put in the beam of some imaging system. And on the other side of it, you get an image of the phantom, which you know what you started out with because you built the phantom. And what we found is that blur, specifically, this is not news, but blur is not just a number. If you look at all these little circles that we designed, you'll see it on the next slide. You can go to the next slide, in fact. These little circles that you see on this arrangement here are not all going to be curved in the same way. When you take a picture of this, we would love to see nothing but circles because these are all sphere BBs made of tungsten carbide, which show up very well in the imaging system. And what you find is that they're not all circles. They all curve a little bit into ellipses. But essentially, this all starts from the physical question of what shape does the imaging system imprint on these circles, and that allows us to make observations from the imaging system itself. Next slide. So using that phantom that you just saw on the previous slide, we put that into what's called a linear accelerator. This is just one example of an imaging system that we can use this phantom on. And on the other side of the phantom, when we looked at the image, what we found are elliptical shadows. And so this is a quantification of not just blur, but what the field calls anisotropy, which is, in this case, the deviation between circles and ellipses. And Smearlets is just essentially a reconstruction platform that uses this very measurement to correct this anisotropy in the imaging system. Next slide, please. So this is just essentially a proof of concept of the improvement in the image that we were able to make. Importantly, we imaged a fork, which might look a little insane if you don't have any background in image quality, but essentially a fork has line spread functions, and it has local features that are good to improve the registration of the edge spread function. Specifically makes the edges look sharper, which is important for patient imaging. So essentially, with our BBs, what we found is we had a mean roundness error of 4.2% at 70 centimeters from the focal spot, which is where the light comes out if you don't have a ton of background in that. And using our Smearlets, we were able to, at 72 SSD, come up with a 72 times reduction in that mean roundness error. So this is just pretty cool. We were excited about that. So next slide. So now this is sort of the slide about why this is relevant. So I set out to quantify this layer that I think comes a little bit before some of the things that we're doing. We have all these amazing feature extraction engines, like take Bell AI, for example, doing some amazing feature extraction on the skin. We're sort of asking the question of what does a skin layer even look like from the perspective of the imaging system so that we can improve those feature extraction methods downstream. And essentially, we just see ourselves as one layer in this library that's attached to the physics picture, which is, I was lucky enough to do my master's research in this. I care about it very deeply. So anyway, next slide. So to wrap up here, essentially we built an imaging-aware platform using a phantom that we scan. We quantify the deviation of the expectation of the imaging system, and we use that to make a correction on the image. It is our argument here that this imaging correction can help the AI feature extraction library at large, and that's specifically why it's relevant to MICCAI. For some of the
Okay.
OGs in the field, how much time do I have left?
Sorry, no. You need to finish. You
Awesome.
need to
We're done.
finish.
Fantastic. That's cool. If you've seen a SMPTE pattern, it's kind of like that, except for image quality.
Okay. Thank you very much. So now we will have a Q&A session for all the three amazing startups that we saw today, that we saw now. So
Let me kick it off. So
mhm.
also the audience can ask questions, of course. So I hope we saw the response by Diana so from the MICCAI Society. Please feel free to post questions also in the question and answer. I'm sure the startups will have a look at it and give you some responses. We want to have it interactive. The live questions will only be by Alex, Wolfgang, and me, but we might be inspired by your questions as well. So let me kick it off. Thanks to all the three startups for the presentations. Very different directions, all very interesting. I will start with Bell AI. Two very quick questions, just for my right understanding. All of your the input is always the phone camera. Sometimes I saw a lens on the camera, right? But the input for your devices is based on the phone camera, or was it just based on the examples?
Thank you. Dr. Hung, would you like to answer and take that question, please?
Yes, so thank you for the question. The input for our AI can be clinical photo from the smartphone, macro photo also from smartphone, demoscopic image using demoscope,
Okay.
or text.
Okay, so it's okay. So it's not that the doctor has to take their phone in the clinical practice to make an additional picture. They can use the pictures that they anyway use, for example. Okay, perfect.
Yes.
And which models? So you have different models that you use in your setup. Some are for segmentation, some are for detection, some are LLM. Do you develop the models yourself, or do you leverage models that are developed from the research community?
So you're right. We have different type of model from segmentation, detection, and classification. Also, language model too, and we develop all of them by ourselves.
Okay,
And we publish some of them in MICCAI.
that's great to hear. I hand it over to the next judge. I have more questions, but I don't want to take all the time.
Then I'll continue with Wiebke and Conveya. So thank you, Wiebke, for the presentation. So currently, I'm aware of several pharma companies who are building multimodal 3D encoders based on JAPA, where like cross-modality registration is like an important pre-processing step. So this is a big opportunity for you guys. On the other hand, we're seeing also that more and more of the foundation models have registration built in as a commodity step or tooling. How do you defend against that moving forward? How do you see the field is approaching that kind of challenge?
Yeah, thanks for the question. That is, of course, I mean, we are aware we are like in a situation where it's a very recent topic. So I think we have a big advantage because we are planning to have this medical device certification for our whole infrastructure module. And that, of course, puts us in a nice place to be integrated by, for example, Pax Vios, because they don't have to do the certification for themselves, and which is, of course, yeah, a money-related question as well, and yeah. Also,
No,
of course,
thank you.
it's about our performance. I mean, yes, foundation model alone is probably also okay-ish at registration already, or quite good even, but our combination of three modules, one of them I didn't talk about because the patent is still pending, but that I think sets off our approach off from the others. Sorry.
No, no, thank you for that. And actually, on one of your slides, you had the total addressable market where the biggest portion was going for clinical research, where I totally agree with. So, thanks.
I could
Yes.
comment on this and even combine it with a question, actually. We are, as you know, in the same field, and the actually all the disruptions due to AI, image registration is at this point least solved by it. And you can look at also R&D publications at MICCAI. Fewest of them are around image registration. And when you have to do super precise deformable registration, especially also used for interventional scenarios, there's a lot more to solve. So it's really great that you're in that space. It's by no way threatened due to foundation models. It's rather the opposite. You can try to pick the best of all technologies. The question would be, so since we do a lot of these things as well, is about the regulatory pathway you're pursuing, because obviously to really get it working in the clinic, you have to at some point focus on a first clinical application and do all the accuracy and validation and assessment for that application first. So when you want to get like broad, let's say CE and FDA clearance for your deformal registration technology, for which clinical applications would you do it first, or do you think you can do it even more generic in a generic fashion? So what do you
First of all,
certify first? What is your first clinical application?
Yes, thank you for the great feedback, first of all, and thank you for the question. As the first case, we are moving on with radiotherapy because we are directly working together with the radiotherapy department here at the University Hospital Schleswig-Holstein. And that is, maybe I can also give it over to my team member Yuri, who's also here because he's the regulatory expert.
Yes, hello. We would like to start with a specific case. Yes, that's the first entry point, but we would like to generalize the intended use. We would like to try in the validation part or in the clinical data generation as broad as possible with different kind of clinical use cases. Then we can validate in this, then we can start in the clinical investigation. And with the FDA clearance that we have the opportunity with the EU MDR, that's the technical documentation and the FDA commit to the ISO 3485 certification right now. We have a good opportunity to combine both, not directly both clearance, but in very short time frames.
I see. Thanks. So there's even a similar theme between Bell AI and you guys in a way that you have very broad claims about your technology, right? So Bell AI also, if it works on smartphone cameras, demoscopes, or clinical photos, it's very hard to get it accurate in all cases also and prove this with clinical evidence. And the same for Convia, I guess. Now, starting with radiotherapy first is impressive, but also challenging because some of the best deformable registration software that has been out there since decades comes from radiotherapy, right? But if you know you can match the performance there, then that's actually very impressive. But maybe to keep the discussion going, maybe let's ask about the roadmap of Bell AI. So what is your very first product going to look like? Is it a software-only product that really is supposed to work and is FDA approved or CE approved for
That's
all
an excellent.
photos, smartphones, and demoscopes?
Thank you, Wolfgang. That is an excellent question, and we wrestle a lot with the strategy of the go-to-market, as any startup would, right? Given the impact we want to make and everything else. So we have centered on winning doctors' trust. The doctors have to trust it first. And the thing about dermatology, if you were to talk to dermatologists, they look at your skin, they say it could be this or that or the following else, 3 differentials. And if you look at the Nature study, it's all about the top 3, maybe top 4 differentials. So as a image company, and we went to the doctor and said, this is psoriasis. They're like, no, impossible. The skin is a mimicker. So we have focused on doing the top 3, top 4 differentials, just like that Nature study. So long as we are the top 3, top 4, 90% of the time to the doctor, we win their trust. And as such, it's a class 1 device in the EU and a class 1 device in North America. Because we're not diagnostic, we provide references for doctors to then make their own decision support. So today, doctors across 40 countries use our software in their clinic, and doctors are paying for it out of pocket. So that's the good news, right? That's very good news. We don't pretend to be diagnostic until we go to the patient's home, where we definitely want them to self-look at their moles with the dermatoscope and get a differential that the FDA say, yes, go get a biopsy. And that's a roadmap. The roadmap is driven by impact and driven by ability to bring it into the patient's home with our lens and our app. So it is smartphone based. And that's because in the rest of the world, in Africa, in Pakistan, in Asia, every doctor relies on the smartphone for their work and not on the expensive photo finder, $100,000 equipment in their skin. It's a smartphone. So that's the impact. And out of 8 billion people today, 5.5 billion have a smartphone. So it doesn't take much to calculate the impact.
So it's mostly point of care focused then, basically.
Exactly right. It's a great question. And we think it a lot, and we say, let's win the doctor's trust first. And we're doing a very good job of that. I don't know if Dr. Yoon Kim, you're a doctor, you want to comment on that?
Yeah, absolutely. So there's a study in the New England Journal of Medicine that shows that even though there's been medical devices and software that have been approved, they don't really get used. So that's sort of our strategy, is to win the doctor's trust first, because no doctor realistically is going to, listen to what AI tells them to do. And if a patient has some kind of condition or a concern, they want to see a doctor and they want it to be a trustworthy device or advice.
Okay, thank you. Thank you all. I think we will go to the next question.
I think
To
Alex
be-
still had a question for
Oh,
Coral.
so a quick question, and then we will.
Yeah, because we also need to give Corel some space.
Yeah.
So Samantha, many thanks for the presentation. I have to admit that out of all startups, I was extremely happy that I was able to tap into your resources yesterday in my preparation, because your field was absolutely new to me. So small question here. So Linac portal based on my own Linac portal imaging based on my own research, which I did yesterday, is a really small niche. And so question here is, like, does the SmearLights generalize to diagnostic modalities like fluoroscopy, CBCT, where the blur physics are different? So first question. And second one, which I couldn't even answer myself using several foundation models or LLMs, what is your realistic total addressable market?
First of all, yes, the share of Linac is very small. This does reflect to any other fluoroscopy, X-ray, CT, etc.
That's a fantastic question. I really appreciate you asking this. And the reason we started with Linac imaging is just about how available a physicist is to get into an imaging system. I can't just go to a CT scanner and say, hey, I've got a new Phantom, let's put this on. There's a whole PAC system that I have to go through. But the Linac, the linear accelerator, has an imaging system that I have a bit more accessibility to, and that is simply the only reason that I started here. Absolutely, I can translate this application to other imaging modalities. That is our full plan right now. The total addressable market for, we're looking to corner the idea of the second opinion for diagnostic medical imaging. And the market there is, it's somewhat scaled with how much do people trust their current diagnostic imaging system. Of course, the diagnostic imaging system is large. I just don't want to quote you a number that is that full diagnostic pipeline. We're still doing market research. We're a bit early in the foundation stage. But did I answer all the questions? I want to make sure.
Can we quickly clarify what your product is actually? This will be useful. So is it only the Phantom, or is it also a software package that does the deconvolution on fluoro shots that can be used before coma reconstruction, let's say? Or so it's a 2D processing package together with your Phantom, right?
For this imaging system, it will be. For planar imaging systems in general, it will be. The long game here is to hire medical physicists to run this phantom, sort of in the background, with their standard QA practices, and then hire a team of radiologists over time, expand this package that we have for the second opinion software, the auto recognition software, auto pattern recognition, and then sort of have our radiologists be able to interpret images with that in the background and sort of corner that market on the second opinion. I hope that makes sense. If you have any other questions, we'd be more than happy to answer. Thank you for the research, by the way, Mr. Lem. That was fantastic.
Yeah, appreciate the follow-up here. Thank you.
Okay, so I guess we will continue. I see there are a few questions in the Q&A, which is great that the audience engages and asks. So please, the startups, please answer there in the Q&A. And now we will move to the next batch. In the next batch, we have Cube AI in Gen Z and Inox Labs. Cube AI is the presenter here.
Yes, I'm here, Bella. Hello.
Yes,
Can you
hello.
please give the control request to my teammate chat? She already requested it.
Oh,
She will lead the
okay.
control and I present.
Okay, great. Yes, the
Thank
control.
you.
Sure.
Okay. Okay. A radiologist with a great clinical question should need a software team to answer it. I am Miram, and this is QPI, the platform that makes that possible. The demand for imaging is outpacing the number of researchers who can turn that imaging into clinical knowledge. The gap keeps growing, and the reason isn't lack of ideas. It is that the pipeline between a clinical question and the scientific output needs to adapt with this demand. Otherwise, we'll face a crisis. Knowing that the radiologists report burnout, workforce shortage, and the talent is actively leaving the field. Looking beyond the numbers, we will find out that the burnout isn't just from the clinical load. It's from everything around the clinical work, as the infrastructure was never built for imaging research especially. Researchers follow a workflow consisting of 7 stages. At each stage, they switch to a different tool, each requiring its own skill set. They quickly hit a wall when using the tools, trying to query packs with code, pre-process medical images, or run segmentation models. Every step demands learning new frameworks and softwares, and none of these tools integrate seamlessly with one another. Here's QPI closes this loop, one platform that covers every stage from problem formulation to the final paper. Now, let me show you our solution. The QPI homepage offers 2 modes, the standard pipeline and the agentic researcher. Let's start with the standard pipeline. This is an AI-powered medical imaging viewer connected directly to PACS, where clinicians can visualize, annotate, and segment medical images in one place. Segmentation is where most research workflows slow down. QPI solves this by orchestrating tiered foundation models, including SAM, VISTA, Interactive, and Voxtel, allowing clinicians to generate accurate segmentation using a single click, points, an ROI, or even a text prompt. Here you can see a real chest CT, with the lungs segmented entirely in less than 1 minute. For repetitive clinical tasks, research can train a model once and reuse it consistently without writing a single line of code. Through our collaboration with Ain Shams Specialized Hospital, we validated QPI on real pediatric neuroblastoma cases. Tumor segmentation time dropped significantly while maintaining agreement with expert radiologists. And now for our agentic researcher mode, the entry point is as simple as describing your hypothesis in plain language. Cube builds the workflow, the researchers reviews and approves, and then execution begins. The playground gives researchers full visibility into every agent decision. Nothing is a black box. Cube starts by grounding the study in existing evidence, automatically retrieving and summarizing relevant literature before the pipeline is planned. It then generates a full structured research plan, where the clinician can review, modify, and approve before starting. Once approved, agents execute sequentially. Cohort selection, segmentation, feature extraction, modeling, each logging its decision to a shared memory. And the pipeline ends with a publication report ready for review. Each research phase has its own dedicated interface, giving researchers full control over the agent's decision. Here is a cohort view shows the matched cases with inclusion and exclusion criteria. The segmentation POC view lets the researcher accept or reject each mask before the pipeline continues. The necessary features are extracted, ranked by importance, and their relationships visible in dedicated shorts and ready for the modeling agent. The modeling agent runs and benchmarks multiple models automatically, generates performance metrics, and produces different charts for comparison. And last, the report view shows the final manuscript side by side with the compiled PDF. We have validated this across 3 different organs, 3 different task types, all run through the same pipeline. The impact is clear. Dramatically faster studies lowered development costs, and clinicians empowered to focus on the clinical insight, not just on code. Our progress has been supported by strong clinical and academic partnerships. We have collaborated with Shams Specialized Hospital, gaining access to real clinical data used in validation. We also focused in clinical outreach, presenting QBI at a major radiology conference in Egypt, and collecting feedback from radiologists. Our work has also been recognized nationally through competitive innovation programs, including and receiving competitive grants and startup funding support. And last, inspired by MICCAI, starting from the RISE Summer School last year, we are now submitting our first workshop paper and open sourcing our agentic researcher, aiming to give back to the communities that shaped our work. Before concluding, I'd like to acknowledge the organizations and institutions that have supported our journey. And now here's our team. Here are our supervisors. And with that, I'd like to thank you for your time and attention, and we're happy to answer any questions. Thank you.
Okay, thank you very, very much. We will go to the next startup presenter in Gen Z AI.
Hi, Bella. Could you...
Sorry.
Yes, you could go with the control. Can you hear me?
Yes. So you want me to move to slides, or you want to take control?
Yes, you can continue the slides. Thank you.
Okay.
So next slide, please. Okay, thank you very much. So hello, everyone. My name is Benes, and Benes Atamofak, and I'll be presenting our startup. In Gen Z AI, in a nutshell, it's an AI-powered platform that is designed to reduce medical device downtime globally, with an initial focus in low and medium income countries. Next slide, please. As we may all know, medical devices such as MRI, CT, and X-ray play, if I may say, a central role in today modern healthcare provision. So from supporting early diagnosis to guiding treatment decisions, right? However, in most parts of the world, especially in low and medium income countries, these devices are readily unavailable for several reasons. One being that these medical devices are cumbersome and difficult to maintain when they break down. But to be more specific, in this region, there are very few medical device technicians. There are few biomedical engineers. For example, in my country, Cameroon, where I currently reside, a country of about 30 million inhabitants, there are only 2 government institutions or 2 public institutions that offer biomedical engineering courses. To even further support our claims and initial literature, initial findings from our survey, from our ongoing survey, initial analysis from our ongoing survey shows that at any given instance, there's about one medical device which is broken across medical health services within this region, with an average downtime ranging to about a month. And there's very few health facilities practice any form of proactive or preventive maintenance on these medical devices. And now you may ask, what is the implication of this to the service providers and also to the patients? To the patients, if I may, if to start, this means, first of all, delayed diagnosis, increase in risk of healthcare condition getting very severe, and also preventable death. On the side of the healthcare provider, this means, first of all, losing customers, and also income, and also reputation. Next slide, please. So at Gen Z AI, we try to reduce medical device downtime in different phases, right? At the core of our solution is an AI-powered chatbot that has been fine-tuned on medical device manuals, technical guides, and also expert feedbacks. It's also multilingual, supporting many different African languages. Through natural conversation, medical device technicians or operators can have and could have guys. So natural language conversation, they can have they are able to diagnose and troubleshoot these devices. We also support direct connectivity to these medical devices such that we can monitor device usage telemetry informations like temperature changes and vibration to provide predictive maintenance strategies. We also noticed in literature that most medical devices actually in this part of the world are bought from either third-party vendors or donated. And therefore, medical device technicians do not have access to device-specific discussion forums, like PEP Connect, for example, in the case of Siemens devices. And so we are providing a global knowledge sharing forum where it brings together device technicians from this part of the world. They could pose their issues and get feedback from either a chatbot that has been embedded within the platform or from peers within the platform. So we also support general device inventory management. To sum it all, our solution is vendor agnostic, meaning it would work irrespective of the specific device manufacturer, and it is built with a device with the users in mind. Next slide, please. So even though our motivation is first to ensure that there is efficient healthcare provisioning in this part of the world, we're also motivated by the fact that the device maintenance market is actually a lucrative field, worthy of investing time and energy. For example, an analysis for an article published by the US Market Research in 2025 shows that the medical device maintenance market will surge to about 123 billion USD by 2033, from only about 48 billion USD in 2023. And therefore, we are excited to jump into this space, solving a critical solution while looking into the benefit, the potential benefit in it as well, financial benefit. Next slide, please. So here is our team. Here is our team composed of AI and ML engineers, of medical physicists and IoT experts. So thank you very much. Next slide. Yep. Thank you very much.
Okay, thank you. Thank you very much. And the last startup in this batch is Inox Labs.
Yes. So Bella, can you please help me forward the slides for me?
Yeah, sure.
Okay. Hello, everyone. Hello, everyone. My name is Trishan Wagle. I'm one of the co-founder of Inox Labs, and I'm based currently in Nepal, and I'm in my third year of my undergraduate degree in my computer science. And today I'd like to introduce MedCoder X to everyone. So every year, the United States spend over $500 billion on billing and insurance administration. Behind that number is one manual process that happens after almost every outpatient visit. That is to turn a physician's clinical note into a standardized medical code. At Inox Labs, we are building MedCoder X, which is an AI system that reads clinical notes the way that the experienced medical coders actually do. So we are doing autonomous medical coding. Next slide, please. So why is this process still so difficult? This is how outpatient coding actually works currently. A physician writes a clinical note. A certified coder reads it, identifies the diagnosis, and assigns the most specific ICD code that is relevant, and then the claim is submitted. The workflow seems simple, but understanding the clinical language is not simple. Physicians use abbreviations, shorthand, and different ways of describing the same condition. Yet coders must choose from more than 68,000 ICD codes, and which also changes each year. That process takes about 15 to 30 minutes per encounter. And despite all that manual review, nearly 1 in 5 claims are still denied, with denial rates continuing to rise. And the bottleneck is not choosing the code. It's understanding the clinical language. Next slide, please. Okay, so that changed how we approached the coding problem. So most of the AI systems treat coding as a classification problem. They read a note and predict an ICD code. But we believe that's the wrong approach. Experienced coders first understand the clinical meaning behind that clinical note, and only then they assign the specific code for that. So MedCoder X follows 3 layers. First is the clinical language understanding, which uses biomedical transformer models to interpret the physician's shorthand and context. Second, UCCR, which is our concept normalization layer, which links every diagnosis to a standardized UMLS concept identifier, which is Universal Medical Language System. And finally, the system assigns the most specific ICD code. Clinical concepts become the foundation now, and ICD code becomes the output. That single architectural decision is what makes our product fundamentally different. Next slide, please. And it comes directly from the research which is developed in this community. Our architecture builds on clinical NLP research from MICCAI, including clinical BERT, bioclinical BERT, and SAP BERT, together with biomedical concept grounding as well. Our own work checks query, which is under review at the MICCAI DMI workshop, follows the same philosophy of concept-grounded learning. We're also committed to benchmarking the UCCR on MIMIC4 and I2B2 datasets as well, because reproducibility should be a part of product development. That's what we think. And that's why Startup Village is the right place for us, as it allows the research to become clinically practiced. Next slide, please. So here's how we are building it. Everything starts with a physician's clinical note. Our language understanding layer extracts the diagnosis and clinical context. Then in third layer, the UCCR then normalizes those findings into standardized UMLS concepts. Only then does the coding engine assigns the appropriate ICD code with confidence scores and explainable reasoning as well. And we'll validate the code on MIMIC4, I2V2, and other data sets. And over the next 12 months, we'll move from validation to our clinical plot as well by piloting into different clinics and hospitals. And once validated, this architecture will naturally scale. Next slide, please. Okay, so once validated, the same architecture becomes commercially scalable. Manual coding costs between $8 to $15 per encounter per visit. Our goal is to reduce that to $3 to $6, cutting costs by nearly 60%. Hospitals can integrate it through a simple pay per encounter API, so it is API-based pricing, and there is no any upfront cost. And we only succeed when hospitals save time and money, and the cost will reduce once we get a more number of hospitals with us. Next slide, please. So why can't existing companies simply do the same? So many companies already generate ICD codes. So what makes us fundamentally different? The answer is our architecture. Most platforms go directly from text to code, but we go from text to concept to code. That concept layer gives us 4 advantages. First is the portable data. Second is the readiness for any updates in the ICD coding guidelines, which changes every year. Less dependence on massive proprietary data sets, and transparent auditable decisions, which is grounded in the concepts of UMLS. Our advantage isn't simply predicting the better medical codes. It's representing the clinical knowledge differently. Next slide, please. And that's why here today. We are looking for different partners, clinical advisors, mentors, and different things for developing our product. So thank you. We are honored to join the MICCAI Startup Village. Thank you so much.
Okay. Thank you very much. Okay. So now it's time for the Q&A for the 3 startups. Sorry.
Should I start if no one else is?
Yes.
To Cube AI immediately, because this is also really interesting and impactful. I'm wondering about your business model for your platform. You have everything in open source tooling, and for the interactive segmentation components that you integrate, actually, which is super relevant, there are some larger companies and startups trying to offer those services, but you specifically added a lot of open source tools that some of them have strict non-commercial licenses like NN Interactive. So how can you build a business model around this technology? Yeah, or generally, what's your business model?
Okay, I'm Ahmed from TBI. Can I answer?
Yeah, sure.
Okay, regarding this service or like open source tools that have as you mentioned have a license for using it commercially, we are considering that for the open sourcing, or like the demo or the prototype that we showed here and that we will open source. We consider it to integrate as much as I can the open source tools, so it will be easier for others to use it. But when we will use when we use the final application or the final product, we will be considering the models and the tools that are open source, and they are open to use their tools or like use their solutions commercially. So we needed to highlight that the licenses are taken in consideration, of course.
Okay. So you would offer clear? Services around this, but your product would be free also?
actually, one of the versions that we are showed here, when we finish the publication or like the publication is published, it will be open source, so anyone can use it. But when we will write the final product or like the product that will be commercially, we will consider each open source tool that its license optionally is either it give us the option to integrate it commercially or not. If it's not option or like it's not acceptable, we will not integrate it, of course. But all of these tools, open source tools that we showed here, that is integrated, it's for the open source version that will be published firstly for the community to use. Okay.
Okay, more questions?
Maybe a very quick follow-up question on this to QPA. Who would be the user of your research agent?
Okay.
Where, Mustafa?
Okay, mainly and the end user of this research engine will be the clinicians that they have no experience in decoding and in this sort of tasks. As we said, we are trying to make more automation in tasks that need coding, and yeah, most of us need coding and coding experience, engineering experience, AI experience. We are trying to make it just and easier and automated for them. So mainly the end user will be the clinicians that are making their research or trying to make their research. They will use the application or this system to help them to automate this daily tasks.
Okay, thank you. I would have another question for Adinsei, which is a completely different perspective on things that we have seen before. So low and middle income countries. So when I was reading the application, it was a very, very different perspective. So I was very happy that the startup was selected for the pitch competition. It addresses a very important topic. One question that I had was the low and medium income countries that you address often have also low resources and low connectivity. So how does your product actually address this? Because for me, it seems that it always requires connectivity to internet or like at least compute resources locally. So could you elaborate a little bit on that? Because I was not sure if I understood correctly.
Hello? Can you hear me?
Yes.
Okay. So yes, we actually built this. We took that into consideration while we are building these models. So first, our choice of models. So we choose models of different weights. So we choose models of lower weight, which could be deployed offline and running on local servers, small servers within the healthcare community. We decided within the healthcare service.
I think the connection is a little bit disrupted there. Maybe somebody else can answer. Or,
require the use of handling that issue. Hello?
Unfortunately, your connection broke up a little bit. So if you don't mind, you can also answer in the chat. I'm also happy to read it. I don't want to.
Oh, hello. Can you hear me?
Now you're back. Yes, seems to be more smooth.
Okay. Yes. So I was saying that to address the issue of low resources, we incorporate that in our development. So first, we choose model based on different sizes. The ones we could our models which could run online. We choose heavier weight models for that, but we also choose lower weight models. For example, we currently fine-tune a Gemma for 4B that could run on local servers hosted within the healthcare service, and that wouldn't need any external connectivity. Yeah, so that's how we solve that issue. And so we generally with fewer solar panels, we can run a small server that works on 24/7 to serve the healthcare service.
okay, thank you. Any other questions from the jurors?
I would have one question for Inox Labs and for Trishan, who is currently in Nepal. Trishan, it's actually more than a remark than a question, because you mentioned that you are charging based on basic cost savings, right? From replacing the manual coders. Personally, you can explore that. I would actually change the position here and actually talk about positioning a revenue uplift, because the reality in the United States, for instance, if you talk to big healthcare systems, is that the current mistakes in the ICD-10 codes are in favor of the payers, so of the insurance companies. So the healthcare systems, at the end of the day, would actually get more with the correct coding. And I think when you are positioning like this, hey, to the healthcare systems, that they will have an uplift in the revenue because they are currently under coding, I think you will have much better like conversations for your product when addressing the healthcare systems directly. So that's just like a remark here.
Thank you. Thank you so much for your feedback. We'll incorporate that.
Okay, any other questions? I also encourage the attendees to ask questions in the Q&A. I will reshare my screen again.
How would you bootstrap, so to Inox Labs as well, how do you plan to bootstrap your training data? In the optimal case, you're partnering with one large US clinical network, right? And get their submitted receipts and everything. So in between the patients and the insurances, are there any plans to do that, or do you already have partners for that?
Okay, so one of our co-founder is currently based in US, and he's talking to different partners, hospital partners. Actually, he is into the healthcare industry and also in the healthcare research, so he couldn't make it today in the presentation. So we are talking to different provider networks instead of direct hospitals. We are currently talking with the organizations that handles different hospitals so that we can have a greater reach. And also here in the Nepal, we also participated in Harvard Health Hackathon, and we were finalists for it. And we also have partners here in Nepal as well, where we can test our model. So that's how we're going to work and pilot our system.
Excellent. Did you actually have a small booth at RSNA last year already?
Sorry?
At RSNA in Chicago, did you have a booth last year? Because if
no.
If not, you have competition, I'm afraid, but it might have been you. So
sorry, it was not us.
It was not you. Okay, I'll send you who that company was. I'll find it out.
Thank you so much.
Okay, so I think we will move on to the next batch of startups. So Neuropath.
Yes, I've requested remote control, if you can accept that, to move the slides myself.
Yeah, sure. You can do that now.
So hello, everyone. My name is Salma Hassan. I'm co-founder and CEO of Neuropath, which is a unified AI platform for the early diagnosis and prognosis of dementia from brain MRI scans. And this is based on our work at MICCAI 2025 with our 2 accepted papers. So here's the reality of dementia diagnosis today. By the time a patient gets a confirmed diagnosis, the brain has already suffered years of irreversible damage. And dementia, unfortunately, doesn't begin at diagnosis. It begins a decade earlier, but silently. So in Neuropath, what we try to do is to move the diagnosis upstream to the moment it can still matter. Now, sadly, dementia diagnosis is failing at scale. There are 55 million people that live with dementia, and every 3.2 seconds, someone new develops it. And nearly 60% of Alzheimer patients are in low and middle income countries where healthcare resources are most constrained. Yet AD is associated with 22 times higher medical costs. And so millions remain undiagnosed until memory loss, cognitive decline, and brain atrophy are well underway. Today's workflow is broken by design, as subjective observation leads to late detection and missed opportunities for early intervention. And the result is 10 million new cases annually and a $1.3 trillion global burden, and 65% of the patients go undiagnosed. Now, Neuropath changes this from observation to measurement. And the distinction is simple. The current system reacts to decline, but NeuroPath detects risks earlier, predicts progression, and creates a longer window for intervention. NeuroPath analyzes routine structural brain MRIs, the same scans that hospitals already perform, and generates a full diagnostic and prognostic report in under 3 minutes, and is trained on over 10,000 annotated scans, fully automated. And we don't just tell you where the patient is today, we tell you where they're going. I'm not sure if the slides are moving. It's not on my end. But I'll just continue for the sake of time. So for diagnosis, we classify each scan across the cognitive decline.
Salma? Afraid
At the high risk. Oh, sorry. Are we back?
Yeah, we are back, yes. But we lost
Okay.
a little bit the connection. Okay.
What was the last point? So let me go back. Sorry. I think it was here, right? Beyond diagnosis.
Mm-hmm.
So we don't just tell you where a patient is today, we tell you where they're going. So for dementia, I'm not sure if the slides are not syncing on my end. Is the diagnosis and prognosis slide up for everyone?
Yes.
Yes. Okay. So for diagnosis, we classify each patient along the spectrum from completely normal to preclinical to MCI, Alzheimer, or vascular dementia. And then for prognosis, we track structural changes over time, flagging any risk of preclinical MCI patient to developing full onset dementia. I'll go a little bit quicker now for the sake of time. So in under 3 minutes, the pipeline runs all 5 steps, starting with the scan quality control, the bilateral segmentation, the radiomics and foundation model feature extraction, and then our innovation with the spatial temporal graph neural network prediction with the attention score of the top contributing features and regions, and then the fully automated reporting. And the numbers hold up. We achieved 94% multi-class accuracy, 96% on AD versus normal, and 89% on the early stage, which is the most clinically critical windows. And every prediction is traced back to the specific brain structures and feature that drove it. So clinicians will receive calibrated confidence score of the top contributing regions. And this is built for clinical trust. It's traceable, validated, longitudinal, and clinically contextualized, not just a blind directive. And for segmentation, we analyze bilateral structures with multi-view and 3D visualization, and left and right hemisphere are analyzed separately for any asymmetry, and the system is robust to scanner variability and acquisition protocols. The clinical output is built for real workflows, so there's normative grounding, which compares each patient against age-matched healthy cohorts. There's validated visual atrophy scores, as well as the reports are radiology ready with the structural clinical interpretation. And NeuroPath is not just built for the lab, it's also for the hospital. So it's HIPAA compliant, fully encrypted, FDA ready infrastructure and hardware agnostic. So it runs on any standard MRI machine globally, accepting NIFTY or DICOM. 0 new hardware is required, and it can scale seamlessly from a single scan to population level batch processing. So why NeuroPath? Well, the alternative is PET, which is expensive and slow, and cognitive testing is subjective and time intensive as well. But NeuroPath just uses the standard MRI. It will cost a fraction and deliver the quantitative explainable diagnosis in 3 minutes. We started with neuroimaging because that was the fastest path to radiology trust. However, our models are already built and ready for EHR and genetic markers, and as well as a new functional MRI proxy capability based on our accepted MICCAI 2026 paper. This is the team behind NeuroPath, myself and my co-founder, Dr. Mohammed Yaqub, and we also have collaboration clinically with SSMC and NHS Greater Glasgow and Clyde. Today, NeuroPath is live. It's funded by NBZUI, and we have a multi-center clinical trial ongoing, and we're preparing for FDA clearance. So thank you. Our goal is to make clinical grade neuroimaging AI as accessible as a routine blood test, because every month of early detection matters for patients, for caregivers, and for the healthcare system. Thank you. I'm happy to take questions after as well as in the chat. Sorry if I went.
Okay. That's okay. That's okay. I gave you a little bit more time because of the connection issues. Okay. So next one, Praxia. Sorry. Yes, Praxia Tech. Is the presenter here?
Yes. Hi, Bella. How are you?
Hi.
So
Yes.
actually, I have messaged you, right? I think there is a
Yes.
very poor internet issue here in my
Yeah,
side.
but I
If you
think it's
can,
better that if you can present it. I mean,
is it okay? Can you hear me?
yes, we hear you. I think it's better to do it live.
Oh,
You're
okay.
fine.
That's good. Okay, that's good. That's
You
good.
can say next slide if you want. You can take control. Maybe whatever you
No, no,
prefer.
I will. Yeah, I will say I have joined through my mobile. Internet is very
Okay,
slow,
no
so
problem. No
I
problem.
will ask you. Okay.
Okay.
So Sure. So, okay, everyone, and I feel very privileged to welcome you on behalf of Prexitech Private Limited at MICCAI Village. So, today I will be presenting the vision and mission of Prexitech Private Limited in neurodegenerative disease, and I will be presenting how we are unifying all kind of neurodegenerative diseases in a single platform and how we bridges the gaps between the patients, doctors, hospitals, research, and industry. So at Prexitech, we believe every brain tells a unique story and every patient deserves the opportunity for an earlier diagnosis and better future. So if we go through some statistics, as per 2023 data, there is 55 million people are affected from Alzheimer's and 139 millions are projected till 2050. And 1.3 trillion is the cost and 2.3 trillion will reach till just 2030. Next slide, please. And if we see in India, next slide, please. Yeah. If you see in India, 7.4% elderly people are affected from Alzheimer's, and that is around 8.8 trillion. So this is the problem statement. There are different kind of neurodegenerative diseases such as Alzheimer's, Parkinson, multiple sclerosis, and generally it has been diagnosed at the late stage. And standard practices are brain imaging, EEG, and multiple tests. So it is dependent on clinicians' evaluation, and thus that's why variability, long time delay because clinicians are very busy, and limited clinical tools are available in this direction. So there is no automated unified platform which unify all different kind of neurodegenerative diseases as well as different kind of uni as well as multimodal data. Next slide, please. So we are proposing, yes, in Prexitech Private, our solution is to develop an ecosystem. First product is Manas Mitra, which is an initial assessment cognitive test, and the another one is AI powered solution, that is AI for neuro. I will quickly go through one by one both of them. Please go to another slide. Yeah. I think others, Manas Mitra, I don't see it.
Yes,
I
we
think due
have
to
the slide. Manas Mintra, yes.
I think there is internet issue I can see. Okay, so this Manas Mitra is the, I am unable to see. Did you go to Manas Mitra slide, a product of Prexitech? Yes, sure. Yes. I think they're due to internet issue, I don't see. Okay, so this Manas Mitra is a tablet-based and app-based neuro pre-screening for hospital. This is a product which we have already deployed in one of the hospital in Amaltas Hospital Indore, and by the end of this month we are deploying it next other 3 hospitals. So in this, what we are doing here, there's 3 validated assessments. Example, Alzheimer's, Parkinson's. Multiple questions are there in this. So it will help the doctors to do assessment. It supports multiple languages, 9 Indian languages, including English, Hindi, etc. It supports audio and text options. It supports 4-tier result scoring, low, mild, moderate. After the screening, there generates a PDF report, and this PDF report helps the doctor to do further analysis. And we have AI powered health chatbot as well in our Manas Mitra. Please, next slide, please. So we had shown the demo, but I think demo is not supported here. Here we were showing how hospital setup can be done, and hospital do all different kind of assessment. New slide, please. And this AI for neuro is the advanced AI-based diagnosis system. It is a web-based platform. It helps the hospitals to do the diagnosis of the patients using MRI, EEG, and multiple kinds of Uniplus multimodal. So currently we have filed multiple patents in this direction. By the end of this year, we are targeting this 4 hospitals to deploy it. So here it supports early diagnosis, explainability, and it is cloud-based hospital-ready product, and it supports the clinicians to take the decision. For example, clinician asks the patient go to the radiologist, do the MRI. MRI would be done by the radiologist. Radiologist just need to upload the MRI into our system. They just negotiate through their MRI machine, and our machine will do all the pre-processing from the raw data only, and then it do the all kind of diagnosis and reporting. Next slide, please. So here we wanted to show the demo, but I think demo is again not visible. So now let's go to the next slide.
You have 20
so our
seconds.
next technology pipe. Okay.
20
Next
seconds.
technology pipeline is for neuro. Okay, okay. Neurohabilitation and cognitive therapy. That's what we want to do. Next slide, please. So this is our research and development achievements in this field. We have been working till from last 10 years and we have got multiple patents and fundings. Next slide, please. This is our supporters. And next slide, this is our advisory committee from international as well as international platform, University of Oxford, University of Edinburgh, several hospitals from India. And next slide, these are some team members. And this is our
Okay.
address and the email address. And you people can reach out to us like this. Thank you.
Okay. Thank you. Thank you very much. Okay. And the last one is Surge Explore. The speaker is here.
Yes. Would it be possible to have control over the slides?
Yeah, you just need to request control. Can you do
Actually, I
that?
don't see how to do that.
Okay, so you can just say to me next slide because it will take me some time to find the. Okay, so or otherwise in Nejin, maybe I will find you here. Okay, yes, I found you. You have the control now.
Let me check.
Okay, you can start.
I still don't have.
You
Okay.
have.
Hello, everyone, and very welcome to Surge Explore. First, surgical intelligence to train, plan, and report personalized to the surgeons and patients. While demand for surgery grows, hospitals struggle with surgical complications and underutilized infrastructure. This creates massive financial leakage, and the root causes are inefficient training, fragmented planning, and incomplete documentation. In Surge Explore, we fix this end to end. And we start with cataract surgery, the most common surgery worldwide with more than 28 million cases per year, and the number is still growing. Training inside the operating room leads to OR time wastage, high complication risk, and limited practice for junior surgeons. We are developing the first AI-based surgical mentor and surgeon and patient-specific intelligence to deliver scalable and data-driven training before OR. Current preoperative planning is too generic. Surge Explore enables evidence-based planning by digital twin modeling. We help hospitals optimize OR time and maximize throughput while systematically reducing intraoperative and postoperative complications. Manual documentation is a major liability risk. It leads to denied payments and wasteful follow-ups. Surge Explore automates structured and clinically grounded reports. We provide audit-ready data for hospital managers and insurers to streamline billing and ensure precise patient care. The platform is backed by a mixture of expert AI models, which we have developed based on the needs of expert surgeons, validated using multi-institutional datasets and published in MICCAI and other medical image computing venues. Our foundation, the largest datasets of real and wet lab cataract surgery videos, exactly what we needed to build Surge Explore. Surge Explore analyzes wet lab cataract surgery videos to provide personalized and objective feedback on the surgical performance based on the current standards in market. The postoperative documentation module analyzes the real surgical videos and provide insight on the next follow-ups of the patient to reduce postoperative complications. Surge Explore helps everyone around cataract surgery ecosystem. Hospitals get more revenue, training becomes cheaper and more efficient, surgeons get support, and patients get better access to care. And industry already votes yes. Hospitals in Switzerland, EU, Mexico, and Middle East have already partnered with us for early pilots. The current solutions in market are either patient-specific without considering surgeon skill level or surgeon-specific without taking into account patient variabilities. This fundamentally limits their effectiveness, and Surge Explore is the only solution that combines both. MICCAI is where our science was born, and this is the right community to witness its translation into medical device. We have validated product, hospital partnership, and competitive non-dilutive funding. What the Startup Village offers is precisely what we need at this stage. The right audience to establish our credibility, the infrastructure to scale our clinical validation, the talent we are actively recruiting at the intersection of AI and medical imaging, and also industry and clinical connections to turn a validated product to a market-ready one. This is our team. We are coming from the AMI lab out of the Art Center from University of Bern, which also spun out Retina AI and Perivision. On the advisory side, we have key opinion leaders and advisors on scientific excellence, entrepreneurship, regulatory, and business. Thank you very much for your attention, and I'm happy to answer any questions.
Okay, thank you very much. Yeah, so I guess we reached the Q&A session for the 3 startups. So
maybe I kick it off. So thanks to all the 3 startups for the presentations. Since they're close to my research, I have a question for the last startup. Very interesting product. You started with cataract surgery because probably also Bern has one of the best researchers in this field. If I understand correctly, the models that you use and the models that you developed, however, are not restricted to cataract surgery, right? Do you plan to explore other fields as well? So can you elaborate a little bit on that?
Yes, thank you for your question. Actually, our first market is cataract surgery in Switzerland, EU, US, and UK, which represents conservative serviceable obtainable market of $100 million. In the next stage, we want to extend the solution to other ophthalmic surgeries. But this is the best one to start with because it's standardized, it's highest volume, and there is a desperate need for that. And the point is that we aim for acquisition. So depending on for how long we stay in the market, we want to extend to the other ophthalmic surgeries.
Thank you.
Nicola, can I continue, or do you have another question?
Go ahead. I have a lot of questions, but I'll give you the space.
Then I'm moving from the last startup to the first one to Neuropath. Actually, the domain you are operating in is actually quite crowded with well-established startups and scale-ups. So you have IcoBrain from Icometrics, we have Brain Health from Deep Health, just to name 2 of them. And there I already specialized in brain volume analysis, right? And targeting Alzheimer and other neuro diseases. So your advantage, based on what I read and understood, is the spatial temporal graph neural network. But for me, what's unclear is what does it actually change for me as a patient if I'm get the diagnosis really early, because based on the treatment plans available at scale globally, nothing would change for me as far as I'm seeing it. Any comments on that?
Yeah, absolutely. So one of the major kind of, let's say, unique features of our product, as you mentioned, is a spatial temporal graph neural network, which aims to not just look at a single snapshot, but at a whole range of time points, longitudinal. And also what makes it unique is that our graph is actually clinically guided. So it was built in coordination and designed with clinicians that kind of almost understand exactly how the brain mechanism works and embed that and encode it in our graph structure. But going beyond that, we are targeting early diagnosis, but not just any diagnosis, the differential diagnosis. Because unfortunately, misdiagnosis rate is very, very high when it comes to different dementia subtypes. Actually, it can reach sometimes up to 50%, which is why we're focusing on a differential diagnosis. And also, to our knowledge, we are the only tool currently that actually looks at the preclinical stage. So most of the current work nowadays, the earliest they target is mild cognitive impairment, which is already too late. But our own model actually treats the preclinical, and it also incorporates the prognostic aspect to actually predict how long or how fast they're progressing. And hopefully, I know that it's incurable, but now there's a lot of effort into treatment. So treatment choice itself could be something that will be very beneficial with this extra information into play. And also, we are currently, yes, focused on just dementia. However, the platform is very modular. So it can be very diverse in terms of what you apply it to, not just dementia. So the volumetric analysis, for example, the segmentation, the redox feature extraction, even the report generation, all of that can be applicable to a number of different neuro-related diseases. So it doesn't have to be dementia, but we make it as modular as possible. And this is just kind of the first launch of it. And of course, when we incorporate more modalities, that will, of course, improve our unique selling point as well.
No, thanks, Alma. Then a short follow-up question before Wolfgang continues. So I'm aware of several cancer screening programs across the globe, especially for breast and also for lung. Are there any dementia-based screening programs available you're aware of where you could tap in as one of the AI engines?
So there are some screening, but they don't actually use structural MRI at all. So one of the main screening tools are the amyloid PET scans, which are very, very expensive and not routinely available at all, which is why we wanted to kind of tap into this aspect of just focusing on the structural MRI on their own, because they're very accessible and they're very routine, they're very cheap. So even when talking to local companies and hospitals and insurance companies here in the UAE, that's the routine that they go for. So insurance would never kind of allow you to go and run a PET scan without a confirmed diagnosis, which is why we decided to just tap in with this accessible MRI scans that are already readily available and work on that. So there isn't anything from the MRI structural standpoint, but there are others that look, for example, at genetic data or PET scans, which again, we are focusing more on the feasibility to also make it as affordable and as accessible as possible.
Thank you.
Thank you so much for your question.
Okay. Other questions?
We should also ask something to Praxia Tech. A very interesting, diverse portfolio. So, quick question to clarify the roadmap of your company, because you're developing 3 products that have basically nothing in common in terms of the tech stack, right? It's an app for patients. It's some MRI image analysis for the doctors, which seems to have overlap with Neopath. Then you have an AR VR solution for rehab. So you have 3 separate teams working on this, or how do you manage to put all 3 into product, or do you have a certain schedule by which you commercialize those 3?
Hello. Can you hear me? Hello.
Yes.
Yes.
I think your questions I could not hear properly. It lags. Sorry, my internet issue. If you may please repeat the question, please.
You're developing 3 very different products, right? The app for patients, the image processing for doctors, the MRI image analysis, and the VR solution. In which order are you commercializing them, and how do you finance this?
Okay, first we have commercializing the Manasmitra. We have already deployed.
Yeah.
Second, we are under deployment of AI for neuro, that is EEG, MRI, PET scan based solution. And third, we are working on that AR VR based solution that we are most probably by the 6 months of 2027, we'll be developing it and then we'll be deploying and then commercializing it. So Manasmitra AI for neuro, then AR VR based solution.
Great, thanks.
Yeah.
Okay, any other questions? Okay, so if there are no more questions, we will go to the next phase, the voting. Okay, so I will explain a little bit, I will re-explain how it works. So we have the audience vote and we have the judges vote. The judges have a separate form of voting. They have a Google form, so they're not voting here. I will now launch a poll and then everybody can see it. I'm launching it now. So please make sure you see it. You can see that you need to scroll down. Okay, you need to scroll down to see all the startups. And please, each participant, if you can, please choose 5 startups. that you like to see in the next phase. And so I remind you that the 5 startups that are selected will be then, the judges will then go over their material. And of course, the finalists and the top startups will be selected from there, and all the ranking will be done by the judges' vote. But please do participate, because your vote counts. Here you can see, we have our own criteria how to vote. So it's good maybe that you will be also familiar with it and take those things into account. So the criteria that we're looking on is innovation of the technology, the impact of the technology, the quality of the presentation, and the relevance to MICCAI in general, MICCAI Society, the MICCAI topics, things like that. Okay, so like I said before, we have in parallel the judges voting and the audience voting. It will be split 50-50. So we are just having them both unified after that. And then the judges have their own period of evaluation, of in-depth evaluation. And then on July 28th, stay tuned, because we will announce the winners, okay, and the rankings. Okay, and here I will just remind you, remind the startups also what the winners get. So the first place gets $1,000 MICCAI Travel Award, but actually the first 3 startups, they all get free registration to MICCAI 2026, which is in Strasbourg, France this year. And of course the MICCAI Society membership together with it, they get it. And also, they can come, and they will also have a dedicated space at MICCAI 2026 at the exhibition area. So they can actually showcase their startup. They will have a computer, and they can show their product and engage with the community, which is very nice. It was very nice last year. And also we have at MICCAI 2026, we have the networking event, where actually all the startups here, I encourage everybody, if you are in MICCAI 2026, just come there and engage. But the top startups will also get invitation to serve as networking partners, and there will be some splitting into tables and things like that. And also I want to remind you that and encourage you, the startups that are participating today in the pitch competition, you can connect to NVIDIA Inception program and AWS startup program. So just ask for it, and we will do the connection. Okay, and yes, here are our judges, but you saw them today in action. A lot of questions from the judges. And I see, yes, I see a lot of people are voting. And that's good. Here are the list of startups, just to remind you, the startups that we had here. We had the Bell
دیگه
AI.
هستن لطفاً که نتود.
We
هستن
have.
panels.
Sorry?
Well, I cannot vote as a member. Like I joined here, but it says that I cannot vote.
Oh, okay. Yeah, because you are, but that's okay. I mean, it's an audience vote and the jury's vote. So I think it's okay that the panelists cannot participate in the voting.
Yep,
And
absolutely.
I think
None of
we
us can
have
vote.
the votes in, so we can close the vote in a couple of seconds, Bella, and then you keep talking, and I'll prepare the results if you want.
Oh, okay. Yeah, we have 85. Okay,
86.
Oh, 86. Nice. Okay, so I'm ending the poll. Okay, I'm ending it now. Okay, so those are the results of the audience votes. You can
I'm
see
not sure
them.
if the audience can see it, but I can see it. So I
Okay.
can definitely do a little bit
I
of
can
math.
share. Okay, yeah, do the math. Okay, I will share the results afterwards. After we have the final results, I'll also share the audience vote results. We need a little bit attention here, just to keep everybody engaged. Okay, so yeah, I will not just share them for now. And Nicola does her work, does her important work. Okay, so we'll soon find out. Sorry. Yes, we'll soon find out who is the winner. Okay. Do you see my sharing? Or is it gone now? I think I will share again. I will share. Okay, so those are the startups. And we will soon get the results. Nicola, what do you say? Maybe I will release the audience vote for now. And yeah, so meanwhile, I will already release the audience vote just for you to see, but this is of course only 50% of the final ranking. Okay, so I'm sharing the audience vote. You can see it here. So for now, we have Cube AI with 54% of votes. I think this is the largest one. And then we have Neuropath with 34% and Prexia Tech with 37%. I think that those are currently the top ones, but again, it's we're combining everything with the judges' vote, and yeah, okay.
I'm ready.
You're
Everybody
ready. Okay,
as
so you want to
well?
share your screen, or how do you want to announce it?
Let me see. Share from the current screen. Okay.
Whatever you like.
So I'll share my screen.
Okay, so I'll stop sharing and you can share your screen.
If everybody is ready.
No, we are not. Yes, we are. Of course.
My laptop is not ready, it seems like. I'm not able to share.
Oh, maybe I will grant you. Can I grant you permission to share?
Okay, let's do it like this. I'll send you. Should I send you the names, Bella, or should I send you the slide very quickly? What's easier for you?
I don't know, the slide, and I will share the slide.
I'll make a screenshot of the slide, and then, all right, let me just send you the slide deck, the very quick one, and then you can show it from your laptop.
Okay,
Give me a
so
second.
It will take a little bit.
Sorry for that.
That's okay. Attention
Don't
is a
know.
good one.
I did an update on Zoom before this, but somehow it doesn't like me.
It's okay. But we can already see the audience vote. I'm scrolling down. Okay.
Also to create a little bit of tension, you know.
Yeah. It's always good.
And independent of who are the top five startups, please feel free to reach out to each individual startup. So you have the contact details. You can still ask for contacts now in the chat. You can ask them questions. But I think all of them did an amazing job in presenting. They all went through the selection progress of actually participating in the pitch competition. So all 9 of them are already winning startups. So as Bella said, so I'm continuing to talk until you are ready, Bella, right? So as Bella said, we're going to have 5 startups now selected based on this selection that was done by audience and jury members together. The jury members will do homework and go more into the tech, more into the details, and we will do an independent vote. So I won't talk to Wolfgang, I won't talk to Alex. We do our individual votes regarding technology, relevance to MICCAI, and so on, and identify the top 3 startups and the winner. Bella, are you ready? Did you receive my email?
I didn't receive it. Maybe there is an issue with the email or something. You can also upload it to the shared.
The last one.
Yeah, I don't know what's the problem, but
I can maybe bridge a minute while you guys are working on the results to say that all participants exhibited some, not just the fruits of their hard work, but some really impressive traits and skills that they have. And it was very refreshing to also see very different presentation styles. So when you had to condense your pitch to 5 minutes, in some of the presentations, some stuff got lost, but also every single one of you conveyed the passion in what their startup does. So kudos to everyone. This was super impressive. Of course, we still have the time to go through the offline material also to really look at the merit of your startup being successful and having an impact. But it was really, really not just entertaining, but impactful to attend this. And it also beautiful how most of you also bridged the link to MICCAI, right? Some of the tech is based on MICCAI publications, and it's front and center in what MICCAI does. So it's really, really nice to see that, I have to say.
okay. Yeah, so I think I do have it here. I will just share it from online, and this will also be okay. Okay. Yes, so can you see my screen?
Yes, beautiful.
Okay, amazing. So yeah, here we go. These are
what is missing?
No,
What
there is
happened?
one. Okay, there is one missing. So you need to tell this one
All
who
right,
is missing.
I'll just tell because
Yeah. So these are
Bell
the 4.
Bell disappeared. So the 5 startups are Bell AI, Convia, Cube AI, NeuroPath, and Search Explorer. So congratulations to the 5 of you, but also to the 9 of you. I think you all, if you go to the next slide, Bella.
Yeah, of course. Yeah.
I don't know what happened. Bell, you're still
Sorry.
there.
You're still there and you're in the top 5, so don't worry. Yeah, so thank you very much to everybody. Thank you to the startups, to the jury members, to the audience. Thank you very much. I like everybody said here. It's you put a lot of the job here. And we are just going over it and checking and judging and but the job is yours and you do a great job and we will announce the winners. Now the jury have additional job to do the voting at the end. Okay, thank you very much.
Thank you so much.
Thank you. Bye bye now.
Okay, thank you.
Bye, guys.
Bye bye.
Thanks.